welcome to the Absolute Recap Biology Edition. I'm your host, Melanie Kingett, and I'll be your guide to scoring a 5. Here at the Absolute Recap, we aim to maximize your understanding and minimize your need for memorization. Each episode will review content, skills, and test-taking tips to help you succeed in May. Your recap starts now. Hi, and welcome to the Absolute Recap Biology Edition. Today's episode will recap feedback. Let's zoom out. We're in Unit 4, Cell Communication and Cell Cycle. Topic 4.5. The big idea is energetics. One of the characteristics that all living things share is the ability to respond to stimuli. These stimuli, or signals, might be external in the organism's environment or internal, within the cell's own biochemistry. Cells function best within a specific range of conditions. Their Goldilocks zone. Maintaining these internal conditions despite external and internal changes is the basis of homeostasis. Let's zoom in. You get home from school and the house is very cold, 62 degrees. Yikes. You shiver in response and the hair on your arm starts to stand on end. So you casually go over to the thermostat and raise the temperature setting to a cozy 70 degrees Fahrenheit. The heat kicks on and everyone's happy. Well, everyone except your parents, who pay the bills and would rather you just put on a sweatshirt. Let's break this down. What is the stimulus? The colder temperature stimulus is detected by the thermostat and a response is triggered, the turning on of heat. But how does the system know when to stop heating the house? There must be a feedback mechanism built into the system to indicate when it is back to its target set point, which you've predetermined by entering the data of 70 degrees Fahrenheit. When your parents get home from work, they change the set point back down to 62 degrees to save money, and again, tell you just to go put on a sweatshirt. There are two types of feedback mechanisms used by living things. First, let's discuss negative feedback mechanisms, their effect on homeostasis, and some examples. If the response reverses the stimulus, the system is operating by negative feedback. This often results in the stopping or slowing down of a process in order to return to a set point, maintaining homeostasis. A great example of this is with body temperature. So when you first walked into the house and were cold, your body shivered and got goosebumps. Both of these responses aim to regulate your body temperature by producing heat with muscle contraction and trapping warm air near your skin. Once you've warmed up, these responses will cease. The same is true when you are overheated with sweat. As sweat evaporates from your skin, it also releases heat, allowing your body to cool down and return to homeostasis. Another example of negative feedback is with the regulation of blood sugar levels. It is important for organisms to have an appropriate amount of glucose available for cellular respiration. As we mentioned in Episode 4, Biological Molecules, one function of carbohydrates for animal cells is long-term energy storage in the form of glycogen. This polysaccharide is specifically stored in the liver and can be converted into glucose as needed. This conversion is controlled by insulin, a hormone produced by the pancreas. Imagine that you haven't eaten in a few hours and your blood sugar levels are lower than normal. Under these conditions, your pancreas stops producing insulin, signaling the liver to convert glycogen into glucose. Once blood glucose levels rise back to normal, the system shuts off. The opposite pathway is also possible. If blood glucose levels are too high, the pancreas produces insulin, which signals the liver to store glucose as glycogen, once again returning blood sugar levels to the normal set points. Individuals with the disease diabetes must self-monitor blood glucose levels due to low or ineffective insulin production. Second, let's review positive feedback mechanisms, their effect on homeostasis, and some examples. Positive feedback is a mechanism that results in the amplification or growth of an output signal. This moves the organisms farther from the set point, disrupting homeostasis. This is a less common pathway, but has specific circumstances for which greater change is necessary. One example is with lactation in mammals or the production of milk in mammary glands. The sensory act of suckling acts as the stimulus to the hypothalamus, a gland that signals the increased production and release of milk. Positive feedback causes amplification. More milk is produced as more lactation occurs. A second example is with the ripening of fruit. Ethylene levels cause changes in the production of different enzymes, allowing fruits to ripen. The first fruit that begins to ripen emits ethylene, triggering the surrounding fruit to also ripen. Over-ripening can occur. Thus, one bad apple can really spoil the whole bunch. Again, positive feedback causes amplification of a response. To recap, the timing and coordination of biological mechanisms involved in reproduction, growth, and homeostasis depend on living things reacting to environmental signals. Maintaining homeostasis is achieved through positive and negative feedback mechanisms. Today's question of the day is about feedback. The onset of labor in childbirth is an example of what type of feedback? For the answer to today's and future questions, please follow us on Instagram at TheAPsoluteRecap. That's the APsolute recap. If you are a student with questions or a teacher with suggestions, we'd love to hear from you. If you have a biology topic or another AP subject you would like us to cover on the Absolute Recap, please email us at TheApsoluteRecap@gmail.com. That's the APsolute recap@gmail.com. The Absolute Recap is produced by Brad Kingett with music by Zach Caruso. Please remember to rate, review, and subscribe wherever you get podcasts. Time's up, pencils down. Thank you for listening to the Absolute Recap Biology Edition. AP is a registered trademark of the College Board. Copyright 2020 Absolute Recap LLC, all rights reserved. Coming up next on the Absolute Recap Biology Edition, Episode 15, covering Unit 4, Cell Cycle and Regulation.